Hi, I'm Tom Lamontagne. I'm Chief Engineer at Element Machine Tools, and today we're talking about unique manufacturing solutions.
Hey Tom, thank you so much for joining me today. How's it going?
Good. How are you, Michelle?
Good, good. So I, of course, know who you are, but would you mind telling our audience who you are, where you're from, and what you do?
I'm Tom Lamontagne. I'm from Element Machine Tools up in the rural counties of Maine. We build machines and controls and manufacturing solutions for various customers in about every industry you can think of.
That's awesome. And what do you do at Element?
What do I not do? President, CEO, financial person, business leader, floor sweep, manufacturing technician, service guy.
Do you want to tell people what your title is at Element?
You want my official title or my card title?
We can do both because there's a specific one that I personally love. So
professionally, I'm supposed to use president, but my card has chief engineer on it.
And I love that. So can you tell us a little bit about how you got that title?
I'm an engineer and a total nerd. We wanted something different on the business cards that would kind of break the ice with people and make us a little more memorable. I'm chief engineer. My VP of sales and marketing is chief sales geek. So.
And has that strategy worked for you so far? Do you get a lot of comments when you hand out those business cards?
Surprisingly well. And it is kind of funny to be able to tell when people actually read your card or just slide it in your pocket.
You know, I never thought of that. That's a really good point, actually, if they bring it up or not. So I know the first time I saw it, it definitely gave me a good laugh, and it's something I'll never forget. So definitely memorable. So I know you wear a lot of hats. So can you tell us a little bit, like, what's a day like for Tom at Element?
What day? So yesterday was doing all the financial stuff for the business, and today is doing interviews, and tomorrow we'll be working on machines.
Okay.
It varies depending on what comes in. Wearing a lot of hats, you have to do it all, so kind of take it in stride. But a lot of it's talking to customers, coming up with solutions, and making those solutions come to reality.
So I know Element does a lot of unique projects. That's kind of its thing. What is the most unique or out of the box project you guys have done?
The most unique? Well, some I can't really talk about.
Okay, that's fun.
The one everybody seems to like the most is baseball bats. And that's one we can talk about. We have a local manufacturer that makes bats for the major leagues. And it's a very interesting process making a bat. I never realized how involved it was, the requirements of grain orientation and weight. But they had an issue with copying bats. Pro players really like a very specific bat shape, and that's what they want. So they would send a bat in, and they had old school hydraulic tracer lathes that would trace that bat and make a copy. The issue there being it's wood. Wood warps, wood moves, wood breaks, wood changes with humidity, and you get a different end product. So they wanted to become a little bit more advanced. They had a limited budget, but we were able to convert their hydraulic tracing machine into basically an electronic tracing machine where they could put a bat in and we would scan it and just pull diameters regardless of warp or break or anything. And then it programs itself and replicates the bat.
That's cool. And how long does a project like that take from start to finish?
So the first one was kind of a mess. Actual work time, I'd say it was probably like 3 or 4 months.
Okay.
All total, it was a lot longer. There was some other parties that were involved that kind of dropped the ball and pieces had to be picked up. But we made it work and come together in the end. And we ended up making a second one for them to do non-round handles. So
you got repeat business, so you did something right.
Yeah. Yep. And we're working on a third project for them right now. So
that's awesome. Is that how you get a lot of your business? Is it normally like word of mouth and then like repeat business, or what's Element's bread and butter?
Pretty much all word of mouth.
Okay.
We help somebody and then they talk to other people, and we've got I think 3 other companies we've worked with because of that project, because he talks to other people in the wood industry and word travels. And we don't just do wood, we do metal and everything else too, but there's a lot of wood manufacturing in Maine, so right now it seems like all I'm working on is wood machines.
Well, it's a good material to work with.
It's a great material to work with. Yeah.
So how did Element get started? Can you tell me like a little bit about the origin story?
Yeah. That goes back a long ways. You want the short version or long version?
We'll do the shorter version.
Even the shorts can be pretty long. So it all really goes back to my college years. I worked at the University of Maine, and I worked at a department called the Advanced Manufacturing Center, which is very careful to say it is not an educational facility. It's really a job shop that exists as part of the university with the intent of advancing manufacturing in the state of Maine. So I got my start there working on all kinds of unique projects. We did engines and weird processing machines to put the bad stuff in bad stuff, buoys and climate change stuff that's floating in the Arctic and stuff in peat bogs in South America and ice coring stuff down in Antarctica. We did everything. So that's kind of where I got my education to start. We were different machines and manufacturing and different systems, and that's where I got introduced to the software that we use now. I was in an early stage of it, and we were able to make a lot of systems at a much more affordable price point for customers because of that software. So fast forward a bit, a couple of the companies I worked for, Thompson Center Arms in particular, we had an issue. We were at the top of the market, so all of our product was super high end, and everything was really tight tolerance, expensive to make, which meant it was expensive to sell. And we had a couple competitors that were trying to come in from the bottom. So we launched a project to try to take the legs out from underneath them and launch a very affordable product, still with the Thompson Center quality. And the only way to do that is to remove the tolerances. So everybody's like, well, let's put the machining in assembly. So then we can machine multiple parts together and remove the tolerancing from each of those individual parts. But nobody knew how to do it. So in I walk with, yeah, we can do that. And using the Mach 4 software, it was Mach 3 at the time, using that software, we'd be able to make manufacturing systems that assembly workers who had never touched a machine before, their only experience with them was walking through the plant and seeing them. They have zero training machining, could walk up to, put parts in and run them and be totally confident they come out. And that allowed us to make a really inexpensive product. So that was kind of the first machine tools that I started making that were really geared towards anybody being able to run them and making them a lot more approachable to people, more so than the standard like Fanuc or at that time we had Yasnak and Mitsubishi controls that are just littered with buttons and lots of numbers and information on the screen that the uninitiated just kind of brain melt. And then after that, I kind of bounced around a little bit, and then the developers of the software asked me to come write some manuals for them for the new version for Mach 4. So that's where that kind of started launching, where they were like, we want this to be truly in with the industrial software. So I wrote the manuals on how the G-codes should work, and they programmed it accordingly. And we kind of went back and forth like that. And that's when I started to realize what it was actually capable of. And all these machines in the past that I had dreamed of doing, I could now do with this software. And that's where Element was kind of born, to become that outlet for producing that product line.
Yeah, sounds like it came out of a niche necessity. So you said something a minute ago, and I'm curious, is Element's unofficial business model, yeah, we can do that?
Actually, if you look at the back of our card, it says, what would you make?
Oh, okay, so close.
Yeah, through my career, I've been known as the guy that doesn't like to say it's impossible. Nothing's ever impossible. It's just, you gotta have a different way of looking at it sometimes.
That's why you and Andres get along so well, because he's kind of the same thing. How do we figure this out?
That makes a machine, and then I make it do things he never dreamed possible.
Yes, and that's something kind of cool about, I think, our partnership is you've helped us in pushing our machines. I wouldn't even say to their limits, because I think we're still every time we think that's it, you take it a step farther. So
we've had a few broken ball screws. So
so we're very grateful for that partnership. So tell people watching, what would they reach out to Element for? So if you're trying to reach out and they're like, hey, I need this, what can you help people with, and where can they find you?
Where can they find us? Well, that's easy. Website, element-cnc.com.
Okay.
That's the easiest way. And people generally reach out to us for manufacturing products that they can't find elsewhere. I mean,
the conventional, really, but they need something special.
Yeah, I mean, we're not stuck to manufacturing any one thing. We don't produce like just machining centers, and that's all we do is 3-axis machining centers or anything like that. We do custom control systems. Where we really excel is making a control system that works with the customer for their specific product or their specific need or their specific system. The name Element really comes from being an essential element of the manufacturing process. And really our goal is to build a system that disappears into the process. And it's just a seamless integration. So when the Thompson Center project is a perfect example. We want to put machines in assembly and have people that don't know how to run machines run them and have it do the right thing all the time, but make it really approachable and easy. We can make a whole custom screen solution for that. Some of the projects that we work with and partner with Level on, we make a very specific control system designed for people to make certain parts, and they don't have any programming or drawing knowledge. Yeah, it's hard to say, really.
No, that was great. That's great. So we're kind of getting to the end of our chat, but we reached out on social media and we asked people what are things they want to know about the industry, and they submitted a list of questions. Would you mind if I ask you one and you help me answer?
Shoot.
Cool. So one of the questions, and it's kind of a simple one, why are CNC machines so loud?
Are they?
Well, that's the question. So maybe this person is in a machine shop with some really loud machines.
Well,
maybe the answer is they shouldn't be.
But sometimes they should be, but it's not always a good thing.
Okay.
It's kind of a loaded question, right? Because there's so many variables there. What's the machine? What are you cutting? What's the material? What are the parts? What's the process? Sometimes they are very, very quiet. Sometimes the cutting process, it actually brings me back to a place I used to work at. We made all aluminum parts. And when I started there, they were very, very old school. They had some super new, super modern for the time equipment, high speed spindles, great machines. So 12,000 RPM spindles, but they were cutting in aluminum with high speed steel tooling at 2,000 RPM. So it was very quiet. But it was also very slow. And I walked in there and like, nope, we're not doing it like this anymore. And I revamped everything. And within 2 weeks, the ladies in the office, because the machine shop was right on the other side of the wall, and one of the fastest machines we had was right on the other side of that wall. They're like, why is everything so loud now? Because the machines were screaming. I mean, but we were on 12,000 RPM and hundreds of inches a minute and really removing material, but that was the right way to do it. And yes, it's loud because you're removing lots and lots and lots of material, and spindle speeds are really fast. But it was good loud.
Okay. So there's a difference between a good loud and a bad loud then, right?
If you have to cover your ears and it's screeching and clamoring and banging, then that loud is very bad.
Okay, good to know.
So that is funny. You can tell a machinist because they can just by the sound, they can tell if something's off or not. And it may be the littlest thing. And you're like, oh, the tool's about to break, and they stop it and they catch it before it happens.
Change, and they go running across the shop to stop the machine before you hear the explosion.
Yeah. It's like a sixth sense. Well, thank you, Tom, for helping me.
What?
definitely a learned behavior.
Yeah, I think that's a lot of years of listening to machines all day. But I wanted to thank you so much for helping me answer that question and for talking with me today. I know I learned a little bit more about elements than I knew before, and I think that's great because that just means I can tell more people about all the awesome things that you do. So I really appreciate you taking the time to talk with me today.
Thanks. Thank you for having me, Michelle.
Thank you.